Today we are going to be talking about Kirchhoff's voltage law, which is also called KVL. So what does the law state? It simply states that the sum of all the voltages in a closed loop must be equals to zero. That is, the sum of all the voltages in any closed loop must be equals to zero. So let's consider this particular circuit. We have a source here, Vs, with a voltage sign, positive and negative. Now we have a resistor with a resistance R1 here, another one R2, and another one R3. So what you need to know in Kirchhoff's voltage law is that the side of the resistor that is closer to the positive side of the voltage source must be the positive end of the resistor. So we have here to be positive and here negative. So this continues positive, negative, positive, negative. So with this, we can assume that the current is flowing from positive to negative in this direction. So we assume the direction of current flow to be this way. That is I. Remember, this is a series circuit. So we can call the voltage flowing through R1 to be V1. The one flowing through R2, we can call it V2. And the one flowing through R3, V3. So to make sure you understand this circuit very well, I can redraw it in this form, which means the same thing. This is R1, R2, R3. So if this is the positive end of the battery, this is negative, this is Vs. So this will become positive, negative, positive, negative, positive, negative. We call this V1, V2, and then V3. So the current is flowing in this direction. This is I. So you can see that this circuit and this circuit are the same. So the resistance, or the resistors rather, are connected in series. So according to Kirchhoff's voltage law, the sum of all the voltages must be equal to zero. So if we start from this point, let's call this point A. We start and move in this direction. The first sign we encounter is what we are going to take. We can as well take the positive sign or the negative sign. So we can take either the second sign or the first sign. If we are taking the first sign we encounter, that is what we are going to take all through the circuit. If we are taking the second sign, that is what we are going to take all through the circuit. Now we are going to take the first sign. The first sign here is negative. So we say negative Vs. The first sign we encounter when we move this direction is positive V1. We come here, the first sign is positive, so we have V2. The first sign is positive, so we have V3 equals to 0 according to Kirchhoff voltage law. This simply means V1 plus V2 plus V3 minus Vs equals to 0. Okay, so for this, let's take the second sign. We are moving from here. We are starting our movement from here. Let's take the second sign. The second sign here is positive. So we can say Vs. The second sign here is negative minus V1. The second sign here is negative minus V2. The second sign here is negative minus V3 equals to 0. So any of this works very well. Taking the first sign, which is negative, so we have negative Vs plus V1 plus V2 plus V3. But when we take the second sign, when we move from this point to this point, we take positive. So this becomes Vs. The second sign here is negative minus V1. The second sign here is negative minus V2. And the second sign here is negative minus V3. This gives us 0. So this is what Kirchhoff voltage law is all about. Let's take an example. Assuming that Vs is equals to 30 volts and R1 is 2 ohms, R3 is 3 ohm, R2 is 3 ohms rather, and R3 is 5 ohms. Since they are connected in series, we see that the total resistance R total will be equals to 2 plus 3 plus 5, and that will give us 10 ohms. Since they are connected in series, the same current flows through the circuit, but different voltages flows across the circuit. So here RT is 10 ohms. So we can see that I is equals to Vs all over RT. So our I becomes, our Vs is 30 volts all over RT is 10 ohms. So we will have 3 amps. So the current that is flowing through the circuit now is 3 amps. So we are going to use both methods to know whether we are right or we are wrong, if we use the first sign or if we use the second sign. Let me clean this off. So looking at it, we see that V1 is equals to R1 all over, sorry, no, IR1, yeah. So IR1, that is for V1, V2 equals to IR2, and then V3 equals to IR3. So we can say that V1 equals to 3 times 2, which is 6. V2 equals to 3 times, this is 6 volts. R2 is 3. This gives us 9 volts. And then V3 equals to 3 times 5. This gives us 15 volts. Now we've gotten 6, 9, and 15. Now let's use our first method to see, to confirm whether we are right or we are wrong. Now, we are going to take the first sign, which is negative. Remember, Vs is 30 volts. So we take 30 minus 30. First sign is here, plus V1, which is 6, plus V2, which is 9, plus V3, which is 15. The answer will give us what? 0, because this is minus 30 plus 30 equals to 0. That satisfied our KVL, that is Kirchhoff's voltage law. If we still use this method, still the same thing. If we use method 2, we see that we start with the positive sign. That becomes 30. Here we take the negative sign, minus 6, minus 9, minus 15 equals to 0. 30 minus 30 equals to 0. So you can see we've verified that no matter the method you are using, your answer must be the same. So depending on which direction you want to take, whether you want to take the first sign or the second sign, you still arrive at the same answer. Whether you want to take first sign or second sign, you still arrive at the same answer.